Have you ever wondered about the strange and inexplicable mysteries of the universe? Physics, that remarkable field of science, is a cornucopia of such mysteries. It is a vast ocean, filled with riddles and enigmas, waiting to be explored. It is the backbone of our universe, the very fabric that weaves everything together, from the smallest particles to the farthest galaxies. In the grand tapestry of existence, physics threads the needle, stitching together our understanding of the cosmos. It is a realm where the impossible becomes plausible, the implausible becomes probable, and the probable becomes certain. Yet despite its inherent beauty and complexity, physics remains as elusive as it is enlightening. Today we embark on a journey into the heart of this fascinating field. We will dive into its deepest depths, scale its highest peaks, and traverse its broadest landscapes. As we journey, we will unravel the mysteries of three of the most intriguing phenomena that physics presents to us: quantum entanglement, time dilation, and the double-slit experiment. Quantum entanglement, a phenomenon so strange that even Albert Einstein referred to it as spooky action at a distance. It defies our conventional understanding of the world, suggesting a deep yet unexplained interconnectedness at the quantum level. Time dilation, the idea that time can stretch and squeeze depending on how fast you're moving or how strong the gravitational field around you is. It's a concept that challenges our everyday perception of time and brings science fiction fantasies within the realm of scientific possibility. And finally, the double-slit experiment, an experiment so baffling that it forced us to reconsider the very nature of light and matter. It presents a world where particles can act as waves and waves as particles, blurring the lines between the two. Each of these phenomena, in their own unique way, pushes the boundaries of our understanding, nudging us closer to the edges of the known and into the realms of the unknown. They invite us to question, to ponder, and to marvel at the wonders of the universe. So, fasten your seatbelts and prepare to have your mind blown by the fascinating world of physics. Imagine two particles linked in such a way that the state of one instantly affects the state of the other, no matter the distance. This isn't science fiction, this is quantum entanglement. In the realm of quantum physics, where the rules of the macroscopic world we're familiar with cease to apply, resides a phenomena that seems to defy logic. Quantum entanglement, as it's known, is a strange and fascinating aspect of quantum mechanics. It describes a situation where multiple particles are linked together in such a way that the state of one particle is immediately connected to the state of the other, no matter how far apart they are. To visualize this, let's say we have two entangled particles. We'll call them Alice and Bob. If Alice is spinning in one direction, Bob will be spinning in the opposite direction. The peculiar thing about this is, even if Alice and Bob were separated by the vast expanse of the universe, a change in Alice's state would instantly reflect in Bob's state. This concept so baffled even the great mind of Albert Einstein that he referred to it as spooky action at a distance. He couldn't reconcile how information could seemingly travel faster than light, a speed limit set by his own theory of relativity. However, modern quantum physics embraces this entanglement as a fundamental aspect of the quantum world. But how does this happen? Well, the truth is, we're still figuring it out. Despite the many theories and experiments conducted, the exact mechanism behind quantum entanglement remains one of the great mysteries in science. Could it be due to hidden variables we haven't discovered yet? Or is it a result of the interconnectedness of the quantum world, where separating two particles doesn't truly sever their connection? The quest for answers continues, driving scientists deeper into the strange and fascinating world of quantum mechanics. Quantum entanglement, a phenomena that continues to perplex and intrigue scientists around the globe. What if you could age slower than your twin? Sounds impossible, right? Well, welcome to the world of time dilation. Time dilation, a concept that could have been lifted straight out of a science fiction novel, is a genuine phenomenon grounded in the principles of physics. It's a peculiar concept that suggests that time doesn't flow at a uniform rate for everyone and everything. Instead, it can stretch and squeeze like a rubber band, depending on two key factors: your speed and the gravitational field you're in. Let's first consider speed. According to Einstein's special theory of relativity, the faster you move through space, the slower you move through time. It's a bit like running on a treadmill. The faster the treadmill's belt moves, the harder it is for you to make forward progress. In the case of time dilation, the treadmill is time itself. Now let's talk about gravity. This is where Einstein's general theory of relativity comes into play. It stipulates that the stronger the gravitational field, the slower time passes. This means that if you're standing on a mountain peak, time is passing ever so slightly faster for you than for someone at sea level. Sounds bizarre, doesn't it? But this isn't just theoretical. It's been proven by experiments, most notably the Huffle-Keating experiment of 1971. In this experiment, atomic clocks were flown around the world on commercial airlines. And when compared to stationary atomic clocks, they showed a slight but measurable difference in time. This gave us tangible proof that time can indeed stretch and squeeze. So, next time you're running late, maybe you can blame it on time dilation, or perhaps it might make you think twice before climbing that mountain. After all, who wants to age faster than necessary? Time dilation, bending and stretching the very fabric of time itself. It's a strange, mind-bending concept. But then again, isn't that what makes physics so fascinating? Light, is it a wave or a particle? The double-slit experiment, one of the most famous experiments in physics, says it's both. Let's dive into this enigma. Imagine a wall with two slits, behind which is another wall where we can record the pattern of light landing on it. If we shine a light at the wall, what would you expect to see on the recording wall? You might think logically, you'd see two bright lines corresponding to the slits. And you'd be right if light behaved solely as particles. But here's where things get peculiar. Instead of two lines, we see multiple lines, bright and dark, like a barcode. This pattern is known as an interference pattern, a phenomenon usually associated with waves. How can this be? Well, waves such as those on a pond create similar patterns. When two pebbles are thrown into a pond, the ripples they create overlap. In some areas, the peaks of two ripples meet, creating a higher peak. In others, a peak and a trough meet, cancelling each other out. This is called interference, and it creates a pattern of calm and disturbed water, akin to the pattern we see in the double-slit experiment. But wait, there's more. If we slow things down, sending through one particle of light, a photon at a time, the interference pattern still emerges over time. Even though it's one photon, it seems to interfere with itself as if it's passing through both slits simultaneously, like a wave. However, if we try to observe which slit the photon goes through, the interference pattern disappears, and we're back to two lines, as if the light is behaving like particles again. This mind-bending experiment illustrates that light isn't just a particle or a wave, but both. It's a phenomenon known as wave-particle duality, a cornerstone of quantum physics. The double-slit experiment, a testament to the strange and dual nature of light. These phenomena are just a few of the mind-boggling mysteries that physics presents us. Let's take a moment to revisit the intriguing marvels we've uncovered. Quantum entanglement, a phenomenon so strange that even Albert Einstein famously referred to it as spooky action at a distance. It's the enigmatic dance where particles become intertwined, mirroring each other's states instantly, regardless of the vastness of space between them. It defies our everyday understanding of the world, and yet, it's a cornerstone of quantum mechanics. Then there's time dilation, the mind-bending concept that time isn't a constant but rather a relative entity that can stretch and compress based on speed and gravity. It's an idea that sounds more at home in science fiction than reality. Yet it's a fundamental consequence of Einstein's theory of relativity. It challenges our perception of the universal ticking clock, suggesting that time is more like a flexible fabric than a steady stream. And who could forget the double-slit experiment? A simple yet profound experiment that reveals the dual nature of light and matter. It shows us that particles can behave like waves, creating interference patterns, and yet also behave like particles, moving in straight lines. It's a mystery that plunges us into the heart of quantum mechanics, showcasing the paradoxical behavior of the quantum world. Each of these phenomena, in their own unique way, challenges our understanding of the universe. They invite us to question, to ponder, and to marvel at the wondrous complexity of it all. They depict a universe not of isolated events, but of intricate interconnections and astounding paradoxes. A universe that's less like a simple melody and more like a symphony of mysteries. It's a symphony we are only just beginning to understand, and yet it resonates with the beauty and complexity of the cosmos. It's a symphony that continues to captivate us, to inspire us, and to compel us to delve deeper into the heart of existence. And so, we continue to explore, to question, and to marvel at the symphony of mysteries that is our universe.